Today on Here's Looking at Euclid, we're going to review Euclid's definitions of boundary, figure, circle, what it means to be a center of a circle, the diameter of a circle, and a semicircle. And we'll talk about the circumference as well, although he doesn't define that. So here's looking at Euclid, coming straight at you. So definition 13 of Euclid is the definition of a boundary. A boundary is that which is an extremity of anything. So if you look at this notepad, right, of course, the extremity is the outside of the notepad here. So that would be the boundary of the notepad. It's the extremity of the notepad. Similarly, in my office here, right, if you look at the walls of the office, those walls serve as a boundary, right, of the office, because again, it's the extremity of the space in the office. So with figures, that'll be the next definition, right? Figure is that which is contained by any boundary or boundaries. So again, we're going to be dealing with squares, triangles, and circles, mainly in plane geometry. And we also, again, deal with parallelograms. So that's going to be the first book of Euclid, is mainly triangles, squares, and parallelograms. But these are figures. The figures are contained by the boundaries. Again, squares have, again, 4 sides, right? Those are the boundaries. The triangle has 3 sides. Those are the boundaries. And a parallelogram, 4 sides. A circle is contained by 1 boundary, right? It happens to come back on itself. So that is the definition of a figure, is that which is contained by any boundary or boundaries. That's definition 14. Definition 15 is the definition of a circle. We'll do a lot of work with circles, especially in book 3 of Euclid. So a circle, defined by Euclid, is a plane figure contained by 1 line, there it is, such that all the straight lines falling upon it from one point among those lying within the figure are equal to one another. So that one point in the figure is a special point, and that's definition 16. That's called the center of the circle. So as long as you have a plane figure contained by 1 line such that all the straight lines falling from that center to the boundary, which in this case in a circle is called a circumference, as long as all those straight lines are equal to each other, right? Sometimes we put tick marks to denote equality, right? Then that figure is going to be called a circle. And the point within the circle from which all the straight lines fall that are equal is called the center. Now, there is a special line in a circle. Again, there's the circle, there's the center. That if you were to draw a straight line through the center and terminate on the boundaries or the circumference of the circle, that straight line is called the diameter, and that's definition 17. So a diameter of a circle is any straight line drawn through the center and terminated in both directions by the circumference of the circle. And such a straight line also bisects the circle. So this straight line will cut the circle into 2 equal parts. So that is a special straight line. Sometimes in monogeometry, we'll talk about chords, right? Which are straight lines that terminate on the circumference of the circle, and the diameter is a special chord, namely a straight line that goes through the center of the circle. And then lastly, definition 18 is the definition of a semicircle. And a semicircle is a figure contained by the diameter. Here's the diameter, right? Contained by the diameter. And the circumference cut off by it, right? And the circumference cut off by it. So this is part of the circumference. It's cut off by the diameter. This will be called a semicircle because it's half the circle. And so those are the definitions. Definitions 12 through 18. In our next video, we'll be talking about rectilinear figures. And that's definitions 19, 20, 21, and 22. And then we'll end with definition 23, which is a definition of parallel lines. So here's looking at Euclid. Thanks for watching. It'd be great if you could subscribe. We are getting very close to demonstrating the very first proposition of Euclid. So it's getting very exciting.